Hello, everyone. Thank you for tuning in to my presentation. My name is Anand Stephen. I am a licensed engineer in the US, in state of California and in New Jersey. Today, I'll be talking about trust and specifically trust and in relation to technological adoption. We know that in our industry, sometimes tech adoption is a little slower than other industries. So drawing upon mm, several fields, I'd like to speak about trust, and hopefully by the end of this presentation, we can walk away as seeing trust as as this critical factor in enabling and of complex technologies that are available right now. So we'll try and go through varied topics. I'll be drawing from computer science theory, some economics, and try and link all this to showcase how trust is really, really important. And crucially, I will speak about the three pillars of, on which we can build trust and some of the practical measures we can take to reinforce these pillars. So with that, you can see some of the topics I'll be covering here. And why is trust important, right? Because trust is this crucial emotion that kind of glues the social fabric. It is the emotion that makes our social interactions tick and function properly. How does it translate into in engineering and in the tech space? I will present um, that reliability, transparency, and ethics. By focusing on these three factors, we can increase trust. And how can we increase trust? For that, I will rely on the famous American economist's work on thinking systems and system one and system two thinking. Well, as I was saying before, like without trust, basically, I think all our interactions, our belief in the social organization, the tech that we rely on daily, everything will come crashing. It's fundamental to our social interaction. It binds our interaction. Similarly, it is key for tech adoption because even though tech is kind of maybe seen as this abstract, logical tool, but if we don't trust it, it's going to be the end product, which is critical infrastructure for our fellow beings. We have to trust in the tools that we're using to design those. So the three pillars that I'm talking about are transparency, ethics, and reliability. So there was this idea in computer science about technology acceptance model, or TAM. Basically, that was what TAM says is that it is the perceived usefulness and the ease of use of a technology. That's all that's required for technology acceptance. Now, those of us who are privileged to be in the position to enable in technology enablement for our peers, we know that's not always the case. So that there's an extended model. Scientists after the TAM model came up with the TAM3 model, they they also stress on the perception of the human subjective experiences as well. Um, why is this important, right? It provides a more nuanced view, especially for our industry, which is low risk industry. We've all experienced many recalls of toys, even cars, but how many of us have seen a recall of a roadway or a bridge, right? That doesn't happen. It's a very low risk industry for good reason, and also focuses on subjective experience of human experience. How do professionals deal with these complex tools? Here, I want to share some anecdotes and conversations I've had with some of my very, very analytical bridge engineer colleagues, right? And these folks are incredibly analytical and thorough and rightly so risk averse because at the end of the day, it's the bridge. The bridge has to stand. Um, they've stated many times, with any new change, they have sleepless nights into how things are adopted, how the bridge would be designed and eventually constructed. So if you think of it, that is a really critical human emotion that the bridge engineer is experiencing as they go through the design process and adopting new tools. So what are some of the factors, practical factors in building trust in technology? And why is it important in AEC field, right? Architecture, engineering, construction. For us, like I mentioned about the low risk factor, low risk tolerance, but further, we also, unlike many other industries, we do have to show and document various options that are not accepted to our stakeholders. For example, if I'm designing a roadway from point A to point B, that might be the best roadway through automation, AI, model-based design. However, there's 5 or 10 other options that are rejected. We would have to show our stakeholders why those design choices not only have it been made, but document those design alternates as well. So it's a little different in terms of design. Moreover, the factor of safety is much higher in our industry and design life is much higher. I would hope that much of the critical infrastructure that we design extends the lifespan of our own lifespan. So in the software industry or any other industry, not any, most industries, the design life typically does not exceed the human lifespan. So these are some of the things that make it a little difficult and different in terms of the trust and the dynamics of trust is gained. So here I draw heavily from Daniel Kahneman's theory of thinking. I think it's really, really useful for us to use his insights and how we can you apply those in terms of transparency, reliability, and ethics, and eventually build trust within these complex modern technologies that are now springing up within AEC space. So what is system one? We all engage in these types of thinking. System one type of thinking is basically, it's a fast, intuitive, and automatic thinking. We all do this. We have shortcuts, mental shortcuts, decisions based on various heuristics, and we come up with that answer, right? It's very efficient. The second one is more deliberate, a very thorough analysis, and considers lots of information, process. We engage in this as well. If we engage in only one or the other, life will come to either a screeching halt, very, very slow pace, everything is system 2, or if we only relied on system 1, everything is based on past information and heavily bias driven. It becomes heavily bias driven, right? And we'll be basically dealing in just instinctual reflex type of actions. So as I go through it, I'll talk about how we can apply transparency and reliability and appeal to both system 1 and system 2 thinking, and in turn that builds trust within the professional community in using any of the advanced tools that are available. As I stated briefly before, trust is a multi-dimensional emotion. It's not like it's so many things. It's like cognitive stuff. There's past experiences, subjective experiences. So in this case, it becomes important to attend to biases, and that can come through dealing with transparency or increasing transparency. So why transparency? I had briefly stated a couple of reasons in terms of the stakeholder engagement and also various design alternates that are necessary. Moreover, speaking from the US context, and I'm sure it's similar in your wherever you're politically in your governments as well, there is increasing demand and need for the decisions that professionals make for it to be transparent. For example, a few years ago in the US, there was an executive order that mentioned um, that defined AI rather as any machine generated output for human input. Now, if you think about that and pause to think about it, that is basically any computer interaction. It's easier with traditional computational design because, in theory, one could go through the algorithm and look at the steps, and you can you can prove the transparency, so to speak. You can see what's going on. However, AI systems are inherently black box systems, right? So what is inside the black box, we only know what comes into the system and what goes out of the system. So how do we increase that? It becomes really, really important for us to increase that. So how can we do that? Within an AI, we can talk about what input is coming into the system and what kind of tests are taken to ensure the expected outputs are there. Now, why does this matter in terms of building trust? Right? Initially, the more transparent we are about a system, even in terms of output or input, it increases the responsibility and answerability to each of these actions. So at that point in time, we're engaging in a so-called system two, a very slow and deliberate analytical thinking. Over time, as transparency in the system is established, people know where to look for and the types of outputs and the types of tests to look for. So it becomes a mental, they're developing kind of a shortcut to see, okay, we have used these technologies and there is a level of transparency with this. Now, intuitively, we understand we can look for errors and biases if they are there. So that is really important in terms of developing from system one to system two and eventually embedding trust in by increasing transparency. I mentioned a little bit about the current AI challenge that we are there. Obviously, it's done like the potential is immense to solve the problems that are there. And how do we circumvent the transparency issue? There's a couple of steps we can take, and they all rely on unit testing of the data that's going in and then what results that are expected, because we cannot open the black box and see how the AI toolbox is functioning, unlike in a conventional algorithmic or computational design. Typically, I mean, there are ways maybe, but in a practical sense, this is what the limitation is. So it becomes even more critical for it to become, for us to like explicitly engage in transparency, actions of transparency, and document it as well. Now, moving on to the second pillar is reliability. So we are in an unique space where we're using complex tools, and we're trying to enable these tools among our peers, or so the reliability of the tool might be there, the actual reliability. However, the perception of reality is equally important. Now, if this is where the TAM3 model comes in, the technology acceptance model 3, the extended version, where human subjective experiences matter. So how do we increase reliability? So let's say an automated contemporary modern technology there's several cost savings, X dollars of cost savings. Now, for a predefined amount of time, we can continue with the older technology that's there, take the results from that and compare it with the newer technology. Yes, is it going to cost more because you're doing two tasks in parallel? Yes, but for a predefined amount of time, the cost offset of using the contemporary modern technology is you can offset the redundancy cost with that. So over time, as users see that the results are accurate and consistent, it increases the perception of reliability. how does this influence system one and system two thinking, right? Tying back to trust. So while it's a deliberate action of these two actions running in parallel for a while, till there is the perception of reliability is improved. Over time, as users see that that it is accurate and consistent, now that becomes a mental shortcut, moves to system one type of thinking, and then the trust in that new technology or technologies have improved. Now, another critical factor is ethics. As engineers and architects, we're bound, like doctors, we're bound by ethics. For example, in the US, the National Society of Professional Engineers we put the health, safety, and welfare of our public as paramount. Um, so as we work on enablement of these new technologies, we can ask that question consistently: is how are these new technologies enhancing the safety, health, and welfare of the public? A simple answer might be the quality is improved, even without getting into the economic efficiency of new technology. It might be the technology is allowing us to look at multiple options and able to forecast um, various options given various rapidly changing climate change scenarios that we're facing. So in that light, depending on the field, whether it's environmental engineering, structural, or what have you, we can speak to how these technologies are enhancing our adherence to the ethics. It's really important. So these three pillars, to transparency, reliability, and ethics. And if we can address these and show how new technologies are addressing these, it can build into our trust in these new technologies. Again, I'm just restating how adherence to ethics also influences. In the beginning, you have to make deliberate steps of how new technologies are adhering to the, ethics, and that's a system two type of thinking. Over time, it goes to system one. It's automatic. Okay, technology A or B, is increasing the way our ethical adherence. So basically, this is just to wrap things up, is that we can bring these three pillars into our quality management plan. We all are in our profession, we have a QMS, a quality management plan. So if we articulate how it's going to increase transparency and reliability and adherence to ethics, and place that within our quality management plan, I think that automatically kind of builds trust in the software. And this slide just pretty much recaps what I've been talking about. Hopefully, you can walk away with the fact that knowing that trust is this central factor in enabling new technologies among our peers. And yeah, so those are some of the strategies I discussed, and I hope you can reach out to me either on LinkedIn, and I'm happy to discuss this further. And like I was saying, trust is the key for our advancing technologies. And these are the three pillars that I think we can reinforce within our quality management plan to advance technology. So with the ultimate goal of building better infrastructure for our fellow living beings and make this a better place. And thank you everyone for your time.